After a hiatus of 20 years, America returns to Mars, not just with one mission, but this is the first of a series of 10 spacecraft going to Mars.
One of the chief architects of this massive effort is the manager of the Mars Exploration Program Office at NASA's Jet Propulsion Laboratory, JPL, and she is Donna Shirley. Dr. Shirley, Donna, nice to have you with us.
How are you?
Great. How are you?
Good.
Good.
We're on our way to Mars. We're happy.
You're happy?
Yes.
We're going. We're actually going?
We are going. Mars Global Surveyor launched last week, and Mars Pathfinder, which is sitting here, is going to launch in about a week.
All right, Surveyor first.
Yes.
What? It's on its way. It's doing
on its
well.
Way. It's doing well.
What's it going to do?
It's going to go into orbit around Mars and take pictures. Some of them will be able to see things the size of a car in some of the pictures. It's going to map the whole planet every day. It's going to look at the clouds.
How long does that take?
A Mars day is just about like an Earth day, 40 minutes longer than an Earth day.
How long will it take to map it?
Oh, about two Earth years.
2 Earth years.
Once it gets there. It has to get there first.
We've got some animation here. What is it we're looking at?
Okay, let's see.
Or we'll be looking at.
We'll be looking at.
With any luck. Yes, we are.
Okay, well, this is Pathfinder. This is the one that's going to launch December 2nd. And this shows how it's going to land. Boy, that's really speeded up.
Okay.
And it lands on Mars, opens up like a flower. The rover stands up and crawls off much slower than that.
Right.
Goes and can climb over rocks, as you can see, even rocks that are almost as big as it is. It's smart enough so it avoids rocks that it can't go over.
Wow.
And it measures the elemental composition of rocks with that alpha proton X-ray spectrometer that you see there right on the back.
Did you hear how she said that? Just.
I've said it 1,000 times.
I'll bet. I'll bet. Now, this is this the actual size?
Yes, this is actual size. This is all we can afford.
Now, what's it going to accomplish? What's it going to tell us?
Okay, this rover is going to tell us what Mars is made out of. The alpha proton X-ray spectrometer actually measures the chemistry of the rocks, and so we'll be able to see if there's titanium or iron or aluminum and how much of it there is. Plus, the lander that you saw very briefly in the movie when it opened up like a flower has a camera that takes pictures in stereo and 12 different colors, so we'll be able to see the colors of the rocks, which will tell us the mineralogy. Also, the rover has cameras. There's a little camera on the back there right next to the alpha proton X-ray spectrometer. I don't even think it's that little thing right up at the top there. If you raise the camera a little bit, there it is. See the little circle right at the top? That's a camera, and so we'll be able to peer very closely at the rocks and see the crystal structure in the rocks. With all that information, we'll be able to tell what Mars is made out of.
Buzz, what do you think of all this technology?
Gee, if we'd had something like this, maybe Neil and I didn't have to go there.
Well, this isn't quite as smart as you and me.
Not quite as smart. Thank you.
Or
Thank
as
you,
agile.
Donna.
Or as agile.
Yes.
Let me.
Or as clever.
Yesterday, the Russians launched a Mars rocket to go to Mars.
Yes, they did.
What happened? It didn't work, but what
well,
happened?
it was a terrible tragedy for the entire space program, frankly, and of course for the Russians. It was a total disaster. But it launched on a proton rocket, very reliable rocket. It had a first stage, second stage, third stage, all worked fine, and evidently the fourth stage just burned out prematurely, and it never left the Earth orbit. It went into orbit around the Earth instead of going on to Mars, and then I understand it just recently splashed down in east of New Zealand.
All right, what is lost scientifically in all of these plans? How much is lost as a result of that?
Well, it's really, the Russians have been working on this since they were planning to launch in '92, then they wanted to launch in '94, and they finally got it together to launch in '96. But it's not just a Russian mission. There were 20 different countries participating in that mission. There was a very big, competent, good German camera. There were 20 different experiments on board. There were going to be 4 landers, 2 small stations that would land rather like the picture of Pathfinder there, and then 2 penetrators that were going to plunge into the surface and measure a couple of meters deep down under the ground and measure what conditions are like down there, and it's all gone.
Slowed us down.
Yeah. Well, it was going to be very complementary with the Mars Global Surveyor spacecraft and the Pathfinder spacecraft.
We have a phone call. Hello.
Hello, yes.
Hi.
Hi. Question that I have is when we do our experimentation on Mars, do we have any plans of determining the geologic age of the planet? And is there maybe an expectation it would be close to what the age of Earth is, say 4.6 billion years?
We're not actually going to be able to age date the planet with Pathfinder or with MGS. We'd need to get a sample back to do that. But fortunately, we have some samples of Mars, which are called the SNC meteorites, or the SNC meteorites that Alan Ladwig mentioned when he was talking about the find. And those have been dated at 4.5 billion years old. And on down to about 3 billion years old is some of the younger ones. And so we believe that the age of Mars and the age of the Earth are very much the same.
Nancy, Massachusetts, hi.
Hi. I was wondering how you know the meteor that was found in Antarctica, how you know that it actually came from Mars.
Well, I'll take a stab at that, and then maybe Jack would like to correct me. But there are isotopes, which are things which there's a number of protons, and then there's a different number of neutrons. So you have a little heavier or a little lighter. The isotopes in the rocks that we believe came from Mars are nothing like the rocks that came from the Earth. Furthermore, they're not as old as the oldest rocks in the solar system, which would be like the asteroids. They've been worked. They've had volcanic action on them. So we know they had to come from some planet. The most likely planet is Mars. Plus, some of them, they found air bubbles of gas trapped inside that's just like the composition of the gas that was found by the Viking lander in 1976.
Donald, Louisiana, hi.
Hello. Good evening. My question is for both astronauts. How long does it take to get from launch to out of the Earth's atmosphere, and how many miles is it? And is it a rough or difficult ride in and out of the Earth's atmosphere? Thank you.
Buzz, go first. You were first.
Well, as I recall, it was a very smooth ride. The G-forces build up, and I think it was something on the order of 11 minutes.
Takes about 10 and a half to 11
until we were
missions.
in orbit, and that, of course, is outside the atmosphere by quite a bit. I'd say you're outside the atmosphere in the first 4 or 5 minutes.
Yeah, we go to 90 nautical miles, and had 4 Gs was our maximum Gs on liftoff. And then coming back, though, in order to make sure you're captured, you have to
by Earth's gravity.
By the atmosphere.
Oh, by the atmosphere.
By the atmosphere, you actually the spacecraft is going at least ours was about 35,000 miles an hour. I think Buzz's was a little bit slower than that.
Feet per second.
But
miles an hour.
Miles an hour.
All right.
I think. Yeah, I'm pretty sure that's what. Because yeah, at any rate, whatever that speed was very large, and we actually could fly the spacecraft. It had a lift vector for those people that are aeronautically inclined, but we oriented that lift vector so we actually dug into the atmosphere so we wouldn't skip out. That would ruin your whole day to skip out. But in order to do that, we ended up pulling 7 Gs. So that was actually the highest G loading of the mission.
After the robots going up to Mars, maybe it's going to be our turn. Will we actually do that? That's coming next. And while we go to this break, consider this. We have not exactly been model citizens. We've left behind a lot of trash up there. Take a look at what has been left and lost in space.